So I just want to kick this off. For those of you that I don't know, my name is Mike Klein. I'm president of the ITS and traffic group at Multilink. We're excited to have this session this morning. We're excited to launch this whole series of programs, a new initiative for us. We are going to be doing every other month. We are going to be doing a similar format with talking about some training, some technical training in regard to our products. The channel partners, our channel partners across North America have been sent the schedule, and they'll be happy to share that with you as to the times and dates and what products we're going to be discussing. The intent of this morning's session is to talk about a product that we're very excited about. Our Pantheon lithium cell battery that we introduced towards the end of last year, beginning of this year. So we have with us Max and Eddie from our engineering group, who are going to be walking everyone through a training session on the battery, on the new product. We are going to keep this session to 1 hour. The microphones, your microphones don't work. So if you have a question, please put it in the chat box. That way, then everybody in the group will be able to see and hear it. And then we will respond accordingly in the chat box. At the end of the session, we're going to have about 10 or 15 minutes. We can have additional questions. You can hold your questions to the end if you want, or you can ask them along the way, and our group will do our best to answer those. So with that, I'm going to hand it over to Eddie, who's going to be doing the presentation. Thank you very much. Eddie?
Hey everyone, my name is Eddie Verovitz, and I'll be taking over the meeting here and providing you a technical introduction to the Pantheon series battery, as well as performing a demonstration of the unit itself. So while we are handing off the host application to my account, give us 1 second so I can get my camera up and running, and we can begin with a PowerPoint presentation. There we go. All right. Okay, so we got everything up and running now. Everyone can see me. Hi, my name is Eddie. So I'll be walking you through this PowerPoint presentation that I briefly discussed a second ago. So let me share that with the screen and get everyone on board, and we can begin. Okay. You good on the? Good. Okay, so we are recording this session here, so we're going to begin with the PowerPoint session. PowerPoint is about 18 slides long. I'll try not to dwell too long on too many things, since we'll be sharing this PowerPoint at the end of the presentation. So we'll begin with the introduction and training of this product. As I mentioned before, I'll introduce myself again. My name is Eddie Verovitz. I am a computer science engineer here with Multilink. I've been here for a little over 10 years now, and I am the technical lead on all of our traffic and ITS power products. My role here in the company, I largely work on the technical firmware development side of things. I've also been involved in developing the printed circuit boards, developing the applications for these power supplies, battery backup systems, our remote power manager, and communication devices to work. And I've also been out in the field performing training, well-versed in the traffic and ITS space. So for any information that you guys might need, for any technical contact information, you may email me here at everovitz@gomultilink.com. And with this presentation, as Mike mentioned before, we are going to be discussing the Pantheon cell battery series. And with this presentation, what I'm going to do is I'm going to walk through the installation process and wiring of the battery, as well as our Optilink BMS monitoring system that comes alongside the battery. We'll discuss the LED, LCD operation. We'll include a little bit of the troubleshooting and maintenance portion to work with this battery while it's out in the field. And then towards the end of this PowerPoint presentation, we'll perform a product demonstration. We'll actually power up EP1100. We'll power up the Pantheon cell battery. We'll allow the system to come up, and then we'll dive into the functional operation of the Optilink BMS itself. All right. So with the introduction of the Pantheon battery series, as Mike mentioned, we've introduced this product late last year. Since then, we've gone through about 2 iterations of this product right now. So the image that you're seeing right now is what we're currently working towards producing in its production form. This Pantheon battery includes lithium iron phosphate battery chemistry. We chose to use this chemistry because it's more predictability, it's more stable, it has a increased power density for more high power, low capacity applications. So if you have a intersection that's running off of LEDs, a more dense power application with this type of battery will allow for longer runtime. With the Pantheon cell battery, typically we're going to see between 2 and 3 times less weight as opposed to lead acid batteries themselves. Our typical lead acid battery might weigh between 70 to 75 pounds, and with 3 to 4 of them, the weight adds up relatively quickly. With our batteries in the Pantheon cell, because of the lithium iron phosphate chemistry, we're able to shave that weight off, become more power dense, and pack much more into a smaller container. The most high capacity battery that we have typically weighs around 90 pounds. With this battery chemistry, we have a superior safety profile, especially over the common lithium ion battery. Minimum maintenance required for this type of battery with a typical lifespan between 10 to 15 years, and that includes up to 10,000 complete cycles, 10,000 complete discharge and recharge cycles. Because of this chemistry, we have a higher depth of discharge as compared to lead acid or AGM style batteries. What this results in is a greater runtime and efficiency, as well as longer battery backup runtime. And if you take a look at the image on the right here, this is the inside of our Pantheon cell battery. You see it's comprised of several different cells with their positive and negative terminals wired in series. Towards the bottom of this image, you can see our LCD and integrated BMS manager. And this is the inside of our batteries. We're demonstrating this to show you that it is comprised of multiple cells. In this case, we're comprised of 15 cells because this is a 48-volt battery. These batteries are composed of prismatic cells all wired in series. As I mentioned, it has an integrated BMS, but with the lithium iron phosphate chemistry, we also include a heater with these Pantheon cell batteries that allows for lower temperature operation. With this series, we also can offer higher recharge efficiency, which reduces the amount of time it takes to recharge these batteries, as well as minimizes energy losses. Within our series, we're currently offering 5 models. So right now we are offering 36 and 48 volt models with 2 different capacities. We have 2 50 amp hour and then 2 100 amp hours. We also have a 5th model that allows for a 48 volt 100 amp hour battery to be rack mounted. With these batteries, because this is our largest capacity battery, we still want this to be mounted on a shelf, but if there is a rack that is available to mount and secure this type of battery to, we make it available to do so. So along with the Pantheon battery, we wanted to offer a tool that would allow you to remotely monitor and manage the battery itself at each individual power supply location. With that, Multilink has developed what we're referring to as the Optilink BMS. What this device is a serial to Ethernet converter. It interfaces directly with each of the Pantheon batteries, has an Ethernet connection on it, and it provides a standalone solution for monitoring our Pantheon cell lithium iron phosphate batteries. It supports both IP version 4 and IP version 6, as well as SNMP versions 2 and 3. This allows for remote monitoring and notifications. It also allows for data collection at traffic control centers to understand the longevity, health of the batteries over a long period of time. Inside each of these Optilink BMS serial to Ethernet converter modules contains an embedded web page that is used to both monitor and configure the device. The device also supports static and DHCP addressing, though static is likely the preferred IP addressing scheme. With this product, while we are working directly with our Pantheon series battery, we do allow for different lithium iron phosphate manufacturers to work with this style of battery. That's largely because the BMSs that we are using and are largely available in lithium iron phosphate batteries use open source protocols. So that allows for our product to interface with other types of batteries. As I mentioned with the Optilink BMS, it does have an integrated web page built into it. So here's a quick screenshot of the summary page that you're introduced to when you first log into this battery.
Want to answer the questions as they come or wait till the end?
Okay, with the introduction, we'll walk through just some pre-installation steps. They're relatively simple. The Pantheon cell battery becomes itself as one package. So it itself is one contained 48 volt or 36 volt battery. With that, you'll buy a package that comes with a mating harness, depending on the UPS that you're using. And when you are purchasing this Pantheon cell battery, your major considerations will be the cabinet that it's mounting in, as well as which size battery you select for the application. Most of these applications require an estimated runtime. Some could be 2 hours to 4 hours, depending on the wattage of the actual load. So two major considerations are cabinet mounting, as well as the battery size. Very simple tools are required to install and maintain the Pantheon cell series batteries. For instance, you'll just need the battery. You'll need the voltage matching of the battery itself to match the inverter that's going to be utilizing the battery power, as well as recharging the system. You'll need the mating battery harness. We offer two different versions. We have two different UPS topologies that Multilink offers, and they have different mating harnesses. So we offer two different options available. You'll use a Phillips screwdriver, as well as a digital multimeter. So a little bit more in depth on the battery harnesses themselves. Here are the two style of connectors that we offer for our product line. So we have both Anderson PP75, which is the black and red connectors that you see in the lower left corner. This is typically used for our EP line interactive series. So this will be used for the EP1100, EP650, and any other variations that may be offered in the EP line interactive series. In the lower right-hand corner, we have our Anderson SB50. This is used for our EDP double conversion series. Note that both of these housings actually use the same internal contacts. So in the event that you may have the incorrect housing harness, you could simply swap out the housings themselves without replacing the harness entirely. Now, I will point out that there is a typo in this presentation. The Anderson SB50 actually works for the EP series, and the PP75 works for the EDP series. So when we issue this PowerPoint at the end of this presentation, that will be corrected and shared with you guys. Okay, so here is just a brief wiring diagram of the Pantheon cell battery series, as well as our Optilink BMS. At the top of the diagram, you can see that we have a large gauge wire harness that would be wired directly to the UPS. We have a small gauge power harness that is connecting to the Optilink BMS. And we also have a communication cable going from the leftmost RS-485 port to our serial port on the Optilink BMS. Now, with our Pantheon cell batteries, all of these batteries must be set to address number 1 for serial communication to be used if you are using the Optilink BMS. I'll demonstrate this wiring diagram towards the end of this PowerPoint presentation when we perform our live demonstration. So the next 2 slides offer the installation procedure for the Pantheon cell battery. So each step here will discuss the necessary requirements. These steps go in order all the way up into verification testing. So we'll just run through them real quick, and then we'll move on. So step number 1, you'll first unpackage the Pantheon cell and inspect the battery for any damage. That could be shipping damage, that could be handling, anything of the sorts. If the battery is damaged, please reach out to your Multilink representative as soon as possible. And in that case, if the battery is damaged, also do not install that battery. If the battery is in good working condition, we'll move on to step 2, which we want to ensure that the battery's power button is off to start. From there, we want to install the battery on its shelf. If there is a 19-inch rack that is available to be used with rack mounting tabs attached to the casing of the battery, we'll go ahead and install and secure that battery to the rack. From there, we move on to step number 4, which is installing the battery harness using a Phillips screwdriver, and we can refer back to the previous slide to show the actual installation of that battery harness. We want to make sure that the polarity is correct and matching when the install is occurring. Moving on to step 5, if you are using an Optilink BMS serial to Ethernet converter, you will also wire its power harness and connect the serial cable to the leftmost RS-485 port on the Optilink BMS. On that serial cable, there are 2 labels on each opposing end of the serial cable, so please note when you are installing that cable that you are doing so to the appropriate port. Okay, moving on to the next step, step 6, which is to ensure that the battery's address dip switch is set to number 1. And again, this is, of course, if you are only using the Optilink BMS device along with it. Otherwise, this address is not required. Step number 7, when installing the power harness, we want to ensure that the UPS battery breaker is turned off before connecting that main power harness to the UPS. If it is off, then go ahead and connect the main power harness to the UPS. From here, we want to turn on the Pantheon cell battery using its power button on the case of the battery. In our demonstration, our on-off button will be shown as a silver on-off button. Once the battery turns on, we want to verify the voltage between the terminals and verify that it is present and appropriate for the selected battery model. If you have selected a 36-volt model, we want to see the battery voltage at 36 volts or greater. If it's a 48-volt model, we want to make sure that the voltage is also 48 volts or greater. So moving on to step 10, after we've allowed the battery to start, the UPS is now up and running, and the LCD menu has become available. We want to enter the protocol menu and verify that the protocol is set to Modbus. Again, this is only required if you are using the Optilink BMS. So the battery breaker is closed in step number 11. We verify that the charger has begun. We can do so during the charging process. We can monitor the SOC, which stands for state of charge LEDs, to make sure that they are flashing. And we can also verify on both the UPS or the LCD on the Pantheon cell battery itself that we are in a state of charge and how much charge is currently flowing into the battery. At this stage, step 12, we want to perform a manual AC power outage to ensure that the battery will continue to operate and provide energy to the load. So during this time, we'll actually disconnect incoming AC power. You can do so with an AC breaker or pulling a line cord. During this time of discharge, the run LED that is displayed on the Pantheon battery will flash. After any set amount of time that may be required to perform a manual power outage, you'll restore AC power and allow the UPS to return to line mode operation. If the unit successfully returns back to line mode operation, confirm that our charge current is now flowing back into the battery. And if so, then this completes the installation and functional operation procedure of the battery. Okay, so with that, your main points of observation of the Pantheon batteries are both the LED and the LCD module. So here is just a brief operation of the available LCDs that are available on the Pantheon battery. We've got our run LED, our alarm LED, and our state of charge. And each of them have 3 different states. We have on, off, as well as flash. And in any one of those particular states, you can indicate if the battery is charging. So, and for instance, if the run LED is turned on, battery is charging. If it's turned off, charging and discharging is disabled. If it's flashing, it means it's in idle or discharging. We have some other operational states for both the alarm and state of charge, and those can be viewed on these graphs here. Now, this LED operation table will be made available in the user manual as well. So for LCD operation, it's largely used to view the operational status of its internal BMS. That BMS provides cell voltage, cell temperature, as well as any alarm status that may be present inside of the battery. And it also allows for the local configuration of items such as the Optilink BMS's serial protocol. Now, in the early release of the Pantheon cell series, we offered a push button style interface to view the BMS information. Our current model now offers a touchscreen LCD display that allows for a bit more upgraded information to be made available. With our LCD operation, anything that's available on the LCD of the Pantheon cell battery itself can also be viewed through the embedded web page of the Optilink BMS if it is in use. So for troubleshooting steps, we'll just touch on a few of them. We'll have a full list of troubleshooting items and any mitigation steps that you might need in our Pantheon cell user manual. But for the first source of troubleshooting is to verify operation through the LCD as well as the LEDs. Any active alarms that may be apparent inside of the Pantheon cell battery will be shown in the status menu and will be clearly indicated as a source of any of the issues that may have occurred. Some of those issues may be cells that are overvolted or under temperature. Overcurrent conditions can occur. In those states of conditions, the batteries will indicate with its alarm LED, and an LCD option will be available for you to view. The second source would be to use the embedded web page of the Optilink BMS. This will also indicate any active alarms if performing troubleshooting remotely. For resources for the Pantheon cell battery, we are currently developing the user manual. Each of these Pantheon cell batteries will be shipping with a QR code that allows for a cellular device to scan the QR code, which will directly link to a high-quality version of our user guide. As I mentioned before, the user guide is still in development and will be released relatively soon. This is nearing towards the end of our PowerPoint presentation, so I'll wrap it up with this presentation point before we begin our live demonstration of the product. For any more of Multilink's offerings, installation, operation procedures, and any support services, please visit gomultilink.com for any of the respective web pages for all of our traffic and ITS products. So with that being said, the PowerPoint presentation is now complete. So I will return back to the camera and we'll start with our live demonstration. So I'm going to start by sharing our screen. So we've got two cameras to choose from. This is one that provides us a little bit more in-depth view of the Pantheon cell. And this is our live demonstration. Excuse me. Okay, so with this live demonstration, we'll begin. So right now, we have set up and wired our Pantheon cell battery. This is our 48 volt, 100 amp hour battery with our rack mounted ears. This is wired to our Optilink BMS. And we have our EP1100, which is our 48 volt UPS system. As we've shown in the wiring diagram in the PowerPoint presentation, we have our main power harness wired directly to the terminals. Our polarities are correct. Because we are using the Optilink BMS, we have its power harness also wired to separate terminals on the battery. We have our serial cable connected to the leftmost port of our RS-45 ports. We have our address set to 1. We have our Ethernet connected to the laptop. And we have an AC power source available for the EP1100. So to begin the operation of this demonstration, we first want to verify that our on-off switch on our battery is turned off. In this case, it is. Our LCD is currently not operational, and we don't have any voltage available on the terminals. So at this time, we'll turn on the UPS. We'll allow our unit to enter into line mode. Once that top LED on the left of the unit turns on, we're in line mode. Our next step would be to close the DC on-off switch on the Pantheon cell. So we will close our on-off switch. Our LCD is now coming up. LCD looks to be a little washed out, but maybe our other camera angle will provide a better view of that shortly. There we go. So our LCD system is up and running. Now we'll close the battery breaker on our EP1100. So if we can see here on the LEDs, after a brief moment of time, maybe 15 to 30 seconds, our charger will start. So during that time, our charger has started. We currently don't have any alarms on our EP1100, so we're not seeing any flashing alarm LED conditions here. We don't have an alarm condition on our Pantheon battery here, but we do have a flashing LED for this row of LEDs. This is our state of charge LEDs, and the leading LED will flash during charge. During this time, you can investigate the LCD menu. As I mentioned before, it's a touchscreen color LCD, providing all of the information such as the voltage pack information, status of the unit, so any information that may provide for overvoltage protection, any current limiting issues that would be available on that screen. On this screen, which may be a little bit difficult to see, this is demonstrating that the current state of charge is in recharge mode. It shows us how much charge current is currently flowing into the the Pantheon battery, as well as what our nominal voltage is. So with this live demonstration, we currently don't have any load connected to the UPS during this time, but that won't prevent us from performing a manual AC outage. So with this, I'll turn off our AC breaker. So now if you can see, our LED operation state has changed on the UPS. This is indicating that we are currently operating from the inverter. The inverter is utilizing Pantheon cell battery to perform inverting operation and provide 120 volts on its output. So during this time, our run LED is now flashing, indicating that it's in a state of discharge. If you were to view this menu, it would also show that we are in a state of discharge and we're currently drawing about 1 amp of current. So with this operation, we're currently operating from inverter. Now we'll go back into line mode by closing our AC breaker. After a brief moment of time, in this case, our qualification time is 3 seconds. We now have our top LED back, indicating that we are in line mode. And after a brief moment of time, we should start to see our state of charge LEDs begin to flash as the battery is recharging. So during this time, we were able to successfully perform a manual AC outage, verify that our battery is fully operational. We have no alarms available to it. We returned the line mode and we recharged, and we are recharging the battery at this time. So with this camera angle, what I'm going to try to show you is during this state of operation, when the Pantheon cell is being recharged or it's in its state of float, the Optilink BMS is periodically polling the Pantheon cell through its serial connection. So approximately every 5 seconds, you may see this LED turn on and off briefly. So what that's doing during that time is it's communicating with the Pantheon cell, updating its information in its embedded web page and backend database, and allowing you to view the information remotely through the Optilink BMS. As I mentioned during the PowerPoint presentation, all of our LCD items that are available here are available through the embedded web page of the Optilink BMS. Okay, so with that live demonstration, we're back in line mode. The UPS is currently recharging the Pantheon cell battery, and we've introduced the Optilink BMS in its communication protocol between the batteries. So this time, I will switch to sharing the embedded web page. And we'll show you how to log in as well as to view that information. Okay. With the Optilink BMS, any browser is available to use. In this case, I'm using Chrome. Each Optilink BMS ships with a static IP address that is secured with the HTTPS protocol. In our case, our default IP address is 192.168.100.1. Okay, so now we are remotely accessing our Optilink BMS, and when we first address this device, we are prompted with the summary page of the product. Now, because this product ships with a static IP address, it's most common that this won't be active on a available internet connection. If that's the case, then our date and time may be off, as you can see here, as well as our Google Maps API may not load correctly if a network interface is not available. with our summary page. Each of these tables provides information about cell voltage, information about the batteries itself, hardware and software versions, pack information, as well as battery status information. As I mentioned in the previous PowerPoint presentation, any of the information that's available on the LCD is available on this embedded web page. So we'll walk through these items. Okay, with the first table here, we have our device ID, which is now currently labeled as a serial to Ethernet converter. The model is the Optilink BMS. Our current software version is 1.0.0, as well as our current hardware release, as well as the Optilink BMS's serial number. So all of that information is available remotely. Beneath that, we have our battery model, software version, hardware version, as well as our serial number and the manufacturing date. Now, some of these items are NA because of this particular battery that we have is a pre-production model. So these are not currently filled in, but we do know the model number, and it does have a serial number. In our production releases of these fields will be fully populated. To the right, we have our Google Maps API. So if this Optilink BMS is placed remotely into the field, you can enter in manually the GPS coordinates for this device's location, and it will display on the map if the Optilink BMS has an internet connection. With these three tables, starting on the left, we have our battery cell information. As I mentioned during the PowerPoint presentation, our 48-volt battery has 15 cells to it. Each of these voltages, as you can see, are changing on the fly. That's because our Optilink BMS is actively updating this information every 5 seconds. With the embedded web page, it also updates itself every 5 seconds. Now, the task of the battery management system inside of the Pantheon cell is to keep all of these cell voltages as balanced as possible. As you can see, most of them are within 1/10 of a volt, which is great. Moving on to the battery pack information, we have several temperature sensors that are available. These are monitoring the banks of cells, as well as a printed circuit board inside of the Pantheon series. During our live demonstration, when we last left off, we left the unit in line mode, recharging. So right now we can see our current charge of state is now 8.9 amps. We can see our battery pack voltage is about 50.69 volts. During recharge state, we can see our amp hour capacity actually increase during recharge. Our state of charge is currently set to 68. State of health is 100%. The design capacity, in case you're not familiar with the model number and its scheme and understanding of the capacity, is shown here. And we also provide a brief history of the number of full cycles that has occurred with the power supply and the batteries. In the rightmost column, our battery status info column, this is where our cell voltage, pack voltage, charge and discharge, alarm, and protection indicators are stored. So right now, anything that's labeled as OK currently does not have an active alarm or is not in a state of an alarm condition or protection. During the demonstration, we left the unit in charge mode, so we see that our charging mode is now active. If we were to do a brief demonstration, which I'll do off screen, of manually performing a AC power outage, we now see that we are in a state of discharge. So the embedded web page is actually changed automatically to show that we're in a state of discharge. It's indicating the cell using this yellow color here, as well as this active indicator. Now that we're in a state of discharge, we can actually see our tables change automatically to a state of discharge. So before we were charging at 8 amps or so, now we're discharging at 1 amp. So I'll place the unit back into line mode, begin the recharging state. So right now we're in a state of idle because the UPS's charger has not come up. But momentarily we should begin discharge, and this table will change automatically. Here we go. Okay, so that's the Optilink summary page. So all of this information is available when you first enter the IP address of the unit. You don't have to have user credentials to log in to see any of this information. We do have some tabs up here that allow for device configuration, SNMP configuration, as well as network configuration. Now, these tabs do require a user to log into these and access these pages. By default, the user's name is user, and the password is multi-link, all in lowercase. When you log into these sessions will last for 12 hours, and then they will automatically end. So if you are connected to the unit and the session lasts for longer than 12 hours, you'll automatically be logged out. So within our device configuration page, we have several different text boxes here that provide information such as the MAC address, our current IP4 version 6 addresses, as well as the model number, serial number, hardware version, software version, and the ability to select and enable the BMS type that this Optilink BMS is speaking to. By default, we have the Pantheon cell BMS selected. Now, on the summary page, we had our device ID is set to this. In these few tables, we're actually allowed to modify the device name, manually enter in the latitude, as well as manually enter in the longitude. With any changes you make, you will click the submit button. The device configuration will be stored, and then you'll be returned back to this device page. Moving on to the SNMP configuration page, in most scenarios, power supplies, Optilink BMS, remote power managers that we offer for Multilink utilize SNMP to provide remote information using UDP access. So with this SNMP configuration page, you can provide a community string, which acts as a password to the device itself. You can set up the trap port, trap IP address, which is the receiver of notifications from the power supply, as well as access type, read and write. And if you have version 3 available to use, you can enable or disable that information from here and fill in the credentials as needed. Last page we'll discuss on the Optilink BMS is our network configuration page. As I mentioned before, each of these products ships with a default IP address in static mode. And on this page, we're currently just showing our MAC address, IP version 4 and version 6, as well as the available items over here to enter in a new static IP address or select DHCP. We also have the ability to enter in a network time protocol address. So if you have a public or private NTP server available to you, this device can automatically update its device date and time, and you can manually select which time zone you are entered in. Right now, we're currently providing time zones for North America. With any of these changes, if you click the submit button, all of these changes will be applied and will require a network reboot, so the device itself will actually reboot if any new network changes are discovered. And the last tab that's over here is our More tab, which allows us to log out of our session. So returning back to the summary page, that is an in-depth look at the Optilink BMS. And I think with this, we will move on to any questions that may have come into the chat that have not been answered during our time here. So I will stop sharing my page and return to camera, and we'll get to those questions.
You want to look through them yourself, or read them off?
Let's see. So I will look through the questions and I'll try to provide an answer. as best as I can. So starting with the Q&A section. Carlos has asked, what about performance on extreme temperatures? The performance of the battery is unaffected during its normal operating range, which is -20°C to 60°C. Now, if you do have the battery option available for a heater mat, this will allow the battery to perform within its noted specs down to -40°C. So we shouldn't see any performance degradation during extreme temperatures unless they're exceeded. Carlos also asked, what about safety against self-fire and self-ignition? With the lithium iron phosphate chemistry, this allows for the battery to be more known and safe conditions. The cells themselves are protected by an air gap as well as the construction of the case. The cells themselves will not self-ignite. There is no thermal runaway in case any of these cells actually do get damaged. And it takes quite a lot to actually ignite or self-fire, as Carlos has mentioned here. I'll move over to the webinar chat. I'll try to field some of these questions. Okay, so Hughes Michaud asks, what are the main benefits and differences in using the BMS to monitor the battery pack instead of only using the information we pull from the UPS? The information that's provided by the Pantheon cell's internal BMS provides much more in-depth information that can include health and longevity and understanding the condition, the actual condition of the cells within the battery. This is a benefit because lead-acid batteries don't offer you this opportunity to do so on the cell-based level. Let's see. Justin Cox asks, does this setup you're demoing require a transfer switch? As Max has pointed out here just beneath the chat, no, we do not require a transfer switch with our demonstration here. We do have one available that we could set up at a different time, but no, the transfer switch is not required. Matthew asks, does the EDP double conversion have lithium profile yet? It itself does not currently have a lithium charging profile, as our EP series does. It's currently in development. We do not yet have an established timeline on when that will be released, but it is in development. Okay, just fielding some more questions. David Clark asks, does this battery change how you would cold start the system? No, it does not. The only additional step you'll have to do during a cold start would be to turn on the batteries first, as in turning on the batteries themselves and then performing a cold start with the UPS. When using lithium iron phosphate, because we have that on-off disconnect switch that needs to be enabled first, as opposed to using lead acid batteries. Okay. Another question here. What are the charging parameters for this battery, such as float charge, start charge, and temperature? With this battery, we don't require any temperature compensation that's handled internally by the battery's BMS. Its float charge is typically up to 10 amps of current. When it comes down to below 1 amp of current, we enter what we call a rest period. This is controlled by the UPS's lithium iron phosphate charge profile. And as far as the start charge, our chargers are typically trickle charged first, and they begin and ramp up their charge current. So there is no minimum charge requirement for the battery, if I'm understanding that charge or that question correctly. J Legs asks, is battery orientation important? In this case, yes, it is important. While the batteries can be mounted on its side due to the weight and construction, we prefer that the battery is mounted in a horizontal position on a shelf or secured to a rack. Paul asks, what is the size of this battery? During our demonstration, this battery is a 48 volt, 100 amp hour battery. Off the top of my head, I do not have the dimensions readily available, but we do have a brochure that shows the dimensions on our website. If you were to go to gomultilink.com and look at our ITS and traffic section under the batteries, you'll see our brochure that offers the dimensions. Thanks, Max. That is the brochure that I was referring to. Okay, a few more questions. Try to bounce back to some earlier questions that may have asked that have not been answered.
Do you still need the temp probe?
Do you still need the temperature probe attached? In our current release of firmware in this demonstration, yes, we need to have the temperature probe attached. And that is only for turning off the alarm at the UPS level. We don't actually need to monitor the terminal voltage temperature of the Pantheon batteries themselves because that's handled internally by the BMS. In the future, when we make a future product improvement and release a new version of firmware for any of our EP or EDP series, we'll remove that requirement. If the lithium battery charge profile is selected, the the temperature probe alarm will no longer be required. David asks, how do you control battery temperature? Because the lithium iron phosphate batteries are very sensitive to ambient temperature, and temperature during charge does not rise too high. Because our Pantheon cell has a internal BMS integrated into it, it's watching each individual cell temperature. If any of those cell temperatures rise above a factory defaulted threshold, then charging can be limited by the battery itself. So inside these batteries, there's two FETs, MOSFETs as we call them. There's one that does charging and one that does discharging. If there is a condition where one of the cells is over temperature, or a bank of them are over temperature, or the ambient temperature is too high, we will disable the charge FET and protect the unit from over temperature during charging. Okay, going back to our question and answer, Carlos has asked, have you gotten any travel safety certificates for the batteries themselves? We have not certified our current batteries for international travel, but they are safe to travel stateside. But we are working on providing that documentation here in the future. And as Carlo points out, I do have incorrect wording inside of the PowerPoint, which I will correct before the distribution of that PowerPoint presentation.
He was sending or asking me to send him the presentation. He just typed in multi-link run.
Okay.
That's all.
Okay. Okay. There may have been some questions that I might have missed. If that's the case, feel free to reach back out afterwards to Mike, myself, and I'll get those questions answered. We've got about 5 minutes left in the session. I think At this point, I'll hand this back over to Mike to wrap things up. As we are wrapping this up, just to note again, we have recorded this session, so we'll be distributing that at the end of the session. We'll also be correcting and updating that PowerPoint presentation and distributing that as well. So thank you for attending. Thank you for giving me your time. Again, if you need to reach out for any technical questions, I'm your guy. Thank you.
Okay, this is the balance of the year. As you can see, as I mentioned at the top of this presentation or top of this meeting, that we're scheduling this for every 2 months. So the next session will be in August, end of August, and we'll go over the line interactive UPS, and then October, the double conversion, and then in December, our smart tracker product. We will then add this will of course bleed into next year, of course, every other month. And we'll then get into some of our other products, some of the new products that we're coming out with that will have been delivered to the market by then, and some of our existing products like signage and whatnot. We've had some requests from our West Coast friends to maybe bump the time. Obviously, this is East Coast time. Bump the time to make it more convenient for them, because they would have to log on at 7 o'clock in the morning. We may bump it up an hour or so to allow them 8, 9 o'clock, which I think would probably be good. So I have to get with Eddie and his group and our technical services group to make sure we have everyone available for that. So with that, I want to wrap this, and I just want to thank everybody for coming. Hopefully it's been valuable for you, and reach back out to our channel partners, your dealer in your area, if you have any further questions, or you can contact any of our regional sales managers or myself directly. And with that, I'm going to stop sharing this. And we appreciate your time and participation, and look forward to seeing you guys next time. Thank you very much.